All right, so on number 11 and 12, in this video we're going to talk about how to sketch the graph of a polynomial that's given to us in factored form. Notice that it's negative. So the first thing you should do is contemplate the degree. Okay, so look at number 11. Can you tell me what the degree of this function is going to be?
3.
Nope. Try again.
2.
Nope.
3.
Try again.
1.
5. The degree of this function is 5 because I've got 3 x's represented here, and I've got 2 more x's represented here. So look at it without the plus 2 and the minus 3 in it. It's like having x to the 3rd power times x squared. That would be x to the 5th power. So this is degree 5. The important part of that is that it is odd. Okay? And I'm hoping, Caitlin, that you have memorized by now that if you have an odd function, okay, odd functions have end behavior that are either like this or like this. Okay? All right, odd ones look like this. Even functions, by the way, have end behavior that either looks like this or like this. All right, so since it's odd, it's going to be one of these two. Is this particular one going to be like the top end behavior or the bottom end behavior? It's going to be like the bottom one, okay? The reason is, like, this is the positive version. I think of it in 2 ways. If I look at it as a capital letter N, can you see that this is like a normal right side up capital letter N? So it makes sense that that would be the positive version. Like the positive one should be like the normal one. But you see that this one is like backwards or something, or upside down. And upside down N would be the negative version. And can you see that this particular function is negative because the negative sign is in front? Another way to look at it is just look at the end, like the right-hand side of it. So if I look at, see the spots where I just put those yellow? If it's negative, the end should go down on the right. If it were positive, the end would go up. So I'm picking the version that goes down. So keep this in mind, that we're doing this kind of end behavior. Well, that's supposed to be an eraser. We're shooting for this kind of end behavior. So I'm going to start off high, and I'm going to end up low. So keep all that in mind. Now, of course, the zeros are -2 and +3. So I should have a 0 here and here. Look at how the +2 is cubed. So at that 0, is it going to go straight through or bounce or be an inflection? This is going to be an inflection. Okay? When it's squared, what happens when it's squared? That's when it's a bounce. If it didn't have anything, that's where it would just go straight through. So I'm looking for an inflection at the 2, well, the -2. I'll put a little I here to remind me that this is going to be an inflection. And I'm going to put a little B next to the 3 to remind me that this is going to be a bounce. Okay? So here I go. I'm going to start off high, like we discussed, and I'm going to do an inflection and then a bounce. And I shouldn't cross the x-axis any other place except for these 2 dots. Okay, so I start off high. So an inflection works like, it's sort of like drawing a parabola. So I'm going to come down and I'm going to curve in, and that wasn't very good. Let me try again. I'm trying to basically draw half of a parabola right now. Okay? Something like that. But when it's an inflection, then you have to curve the other part of the parabola upside down. Sort of like this. Okay, so that's what an inflection looks like. Then I have to curve back around in time to bounce at the next spot. All right, so I'm going to curve back around in time to do a bounce right here. So when you do a bounce, you don't go through at all. Don't let it peak above the line at all. Go right back the way you came. So this is what the picture should look like for this one. All right, notice it has the end behavior that I wanted. It started high and ended low as we knew it would. we had no choice. So once we had to start high, okay, and we had to do an inflection. So when you do an inflection, you wind up going through. So we wound up below the line. So as we approach for the bounce, we just happen to be below the line. Sometimes you'll be below, sometimes you'll be above. So if you're below, you'll just bounce back down. If you're above, you'll bounce up. Just 50-50 chance. All right, let's look at it again for number 11. Let's try this degree thing again.
3.
The degree is 3. Good job, Antonio. All right, can everybody see that the degree is 3?
Yeah.
All right, again, that makes this odd. All right, it's 3 because there's two of these and one of these. And again, when it's odd, that means it's either going to be like a right side up n or like an upside down n. Okay, this time it's going to be right side up because it's positive. So this is our end behavior that we're looking for. So that tells me to start low and end high. Let's see, where are my zeros at? So my zeros are at positive 3, okay, because of the negative 3 here. This one should just go straight through, right? Okay, because there's no exponent. And then I'll have a 0 at negative 1 because of the plus 1. And this one should be a bounce. Okay, so I'm looking to have a bounce here at negative 1. And it should go straight through at the 3. And I'm going to start off low as we discussed. So here I go. I start off low, and I have to come up and bounce off of this point. And then I'm going to swerve around and go through at that point. Okay, so that's what number 12 should look like. So one more time, I keep referring to the end behavior and kind of how you know how the end behavior is going to go. Once you figure out whether or not the degree is even or odd, that tells you how the end behavior is going to go. If the degree is even, it's going to have the end behavior like a parabola. Either both arms will be going up or both arms will be going down like a parabola. So on number 12, you're just only looking at one factor, okay? To understand the degree, you have to look at all of it, okay? So remember, x plus 1 squared, that's like having x plus 1 twice. So if I were to write this out, this would be like x minus 3 times x plus 1 times x plus 1, okay? If you multiplied this all out, in the end, you're going to wind up doing x times x times x. When you do x times x times x, what do you get? X to the third power. That's why the degree is 3, because there are 3 x's. Okay? Like looking at the last problem, number 11, I said the degree was 5 because this is x to the third power, this is x squared. That's a total of 5 x's. Okay? Okay? So always keep this in mind. If the degree comes out to be even, the end behavior will be one of these two. And if it's odd, the end behavior will be one of these two. Okay?